Hello everyone, January 20th. House robber. Old problem. Solved it many times. Fan favorite too. Look at this. 20,000 likes. Only 389 dislike. It's DP and very basic DP I remember. Okay, you are a professional robber. I like the first sentence immediately. Planning to rob houses along the street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems exactly connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Yeah, so if I have a DPI indicating the max money I can rob up into house I, now I'm on I minus 1. Now I'm on I plus 1. So I look back, the maximum, I cannot rob the one. So I either don't rob myself, then I will copy whatever is the previous house, or I rob myself and the two in front of me. That will be the result. So when we build the DP array, we will start with the first one. So the first one will just be that. And then the second one, starting from the second one, I think we need to do the comparison already. Either I don't rob the second one and copy the first one, or I rob the second one and have to go to the front. And it seems like I shall do two. I shall do the first two, right? You do the first two, then it will be fine. You don't have to do any if checks, right? You don't have to do any if checks. Okay, that is the strategy. Let's get it rolling. Get it rolling. All right, so first of all, if len nums, let's just call it n is len nums. It's fine. If n is equal to 1, we just return nums 0. Otherwise, pp and p will equal to nums 0 and nums 1. Because the second house, that's actually should be the maximum nums 1 and nums 0, right? This is the second house. Because up into the second house, you can either rob the second house, or you don't rob the second house, so you have the first house, but you cannot rob the two together. Then we say for I in range 0, 1, 2 to n, we say pp and p, right? Pp will equal to p, p will equal to maximum. If I don't rob the current house, so I will just do p, right? Or I rob the current house, I'll do pp plus nums I, and blah blah blah, I'll return p. Something like that shall work. Let's do this. Oh, hold a second. Oh yeah, we know it can do this. I tried it, the automatic, right? The docstring stuff. Okay, 198 DP. That's one of the classic entry-level DP problem. ON. You know what would be funny? That with all talking like this and eventually we make a mistake. Yeah, let's hope that's not true. Alright. Last time solve it 2020. That was a long time ago. 2020. So 2020, 2021, 2022. Let's see what solution we use in 2022. As the same, right? As the same. Oh, it's actually not the same. This one I extended for I extended further. Okay. Yeah, that's fine. But I do think this is easier, right? Better. Better time, not time. It's the space complexity. Better space complexity. Alrighty, this one is done. We can close this. Move on. Largest element after merge. Oh, that was there we go. That was yesterday's problem. Oh, from right to left, I remember. And we couldn't open it. We could not open this page. Yes, right to left. Okay, let's move on. All right, this is the real deal for today. This is the real deal. Maximum number of groups with increasing length. You're given a zero-indexed array, usage limits of length n. Your task is to create groups using numbers from 0 to n minus 1. Ensuring that each number I is used no more than usage limits I times in total across all groups. You must also satisfy the following conditions. Each group must consist of distinct numbers, meaning that no duplicate numbers are allowed within a single group. So no duplicate numbers are allowed within a single group. Each group except the first one must have a length strictly greater than the previous group. Return an integer denoting the maximum number of groups you can create. Alright, so the first one is length n, so 3. Alright, so we have 1, 2, 3. So you can use 1 time, 2 times, and 3 5 times. My bad, start from 0. You have 0 at most once, 1 at most twice, 2 at most 5. Okay. One way of creating the maximum number of groups while satisfying the condition is group 1 contains number 2, group 2 contains number 1, 2, and group 3 contains number 0, 1, 2. It can be shown that the maximum number of groups is 3. And except from the first one, each group must have length strictly greater than the previous group, and strictly greater than the previous group, and each group must have distinct numbers, and we have these constraints, and then we're trying to find out what is the maximum number of groups we can create. Well, because there can be no duplicates. The last group, the maximum size of the last group is n. Right? The maximum is n. Every single usage limit is larger than 0. Yeah, so the last one must be. Is it true the last one must be though? Like in this case, you can have 0, 1, 2, because if you have 0, 1, 2, I mean you can do 0, 1, 2, and then you don't have any 1 left, right? You don't have any 1 left, so you have 0 and 2, so you can do 0, 2. They have 0, 2 again, but you cannot do another one. In this case, you're gonna do 1 because you do 0, 1 and you use up everything. That is interesting. That is interesting. And you can say you always want to start with 1, right? Because actually, I'm not quite sure. I'm still thinking like greedy wise. We always start with 1, and the second one with 2, and then 3, like doing that way. So the first one you say start with 1, and the second you start with 2, which means you want to find the ones the largest. Like if we sort the things, right? And each time when you use it, you should use it with the maximum repeats, right? If you want to do greedy wise, you want a maximum repeats. So you take some out, right? You take the maximum repeats, okay? So that would be the first. And the second one, you'll take the maximum repeat and the second maximum repeat. And third one will be the same. Okay. So maybe we can do, I'm not sure. I'm thinking about this problem in terms of greedy. That each time when we create this group, we always use the numbers, the values, with the maximum repeats, right? With maximum repeats. And in Python, we can use sorted list. I'm going to try sorted list for this. Sorted list. Sorted lists, we can add, we can update sorted list by adding all values from it. No, that's not the one. Discard, remove. Pop is pop the end. We can bisect. Now we don't really want to bisect. We do want to remove and push it back in, right? We want to remove and push back in. So we want to remove, what's this value? Remove a value from, must be a member. Raise value error. Okay, so in this case, when we start, we can say 0 has a 1 time. So can we do sorted list with two things? Oh, it has key, right? It has key. Did I introduce the key thing? I didn't say, but I guess it's fine. So yeah, we'll do key. I might as well just try it. How do I import? Sorted containers, that's the one. Sorted containers, import sorted list, right? And then equal to sorted list. Can we do, 1 0? Yeah. 2 2. 3 5. So we'll be sort based on 1 2 3. And okay, that's actually not what I want. Let's change it. Bar equal to this. I shall put the other thing first. I think it should be fine. You know what? I don't want to test again. Let's just try it. Yeah, I have sorted list, right? Yep, I have. I mean, it's not sure. I'm not sure if this is going to be right, but Oh, it's not reading from. Huh. That's something we need to resolve. How do we read from my current environment? Like this one, they don't know what this is. Right? They don't know what sorted list is. They just say it's a variable. Okay. Then what? For I, u in enumerate usage limit, array.add, can do u usage and I. Okay. Now once we've done this, then we can say we get the largest, and now we get 2, then we get 3, we get 4, we get 5. So we say rest is equal to 0, and while this oh yeah, that's fine, because I can pop, right? Then what's the 10 to the 5th? Oh, that's not gonna work, because you pop all those, right? And then put them back in. Oh, hold a second. You don't need sorted list, because you can just sort it and you go from back to the front, right? So you sort based on their usage limit, okay, from low to high, doesn't matter, and from the back, you know this one can use however many times, so it will use 1, 2, 3. So that, hold a second, like this, you know this one can use 5 times, at most 5 times, right? And then so this one can support 1, 2, 3, 4, 5, and at most is gonna be the length. You cannot have more groups. Yeah, you cannot have more groups. So you start from the last one, and then you get this. So this can have, and from here at most is 2, to this most is 1. So as we go from right to left, each time just check the maximum, and then we check, and then we check. Hold on. So here, the maximum I can make is, 3 times, 3 groups, right? So this is 3 groups, and then we go to the next one. If the next one is very small, that means it cannot support. So like, it cannot support, like, hold on. Let's say I have something like 5 here. I can do up to 1, 2, 3, 4. I have 5. So this number can support 5 times. And this, instead of 4, I have only 2. Right? And then 1, or maybe 2, 1, 1, like something like this. So this can support 5 times. So at least this needs to support 4 times. But this is only 2. So this can only support 2, which means the maximum is going to be the maximum number for here is only 3, right? Because this one can appear 1 by itself, and then this one can appear 1, and then have this one, and then you can have this one, and then this one, and then that's it. We can't have another one, right? So the maximum is 3. So each one, this is going to plus 0, because plus 1, plus 2, plus 3, plus 4. And then it seems to be sorted, so this has become 3, right? And then this is 4. This one maximum support 4. This one maximum support 5. So it should be 3. Let's give this a shot. Not quite sure, but I think it may have merit. So anyway, in this case, we just need to say res is equal to len usage limits, and then for usage limit I in sorted, okay, UI for IU in enumerate usage limits, okay, reverse equal to true. Okay, UI, oh, see, that's the part I don't like. It just, I will type wrong keys. Okay, for UI, and do I even need I? Seriously, do I even need I? I don't think I even need I. Let me do this one more time. Let me say for you, for IU, dot sort, easier. For I range, we'll go from right to left. Maybe we can go from left to right, right? And each one is its count and then plus. Yeah, so in range, len usage right, len this res shall equal to minimum res and I. No. I believe this, right? And then it's I plus usage limits I, and then we'll return res. Is that right? Nope. Everybody's 1. Because in this one, when we sort it, go right to left. So that's 0, 1, 2. Right? No. So I is I go from 2. Huh, maybe it should be I plus 1. I go from, because this one I need to plus whatever value it is. I need to plus, this one should plus, it should be plus 2. Because I can do this. Because that's the maximum, right? It's the one with the maximum repeats. So, maximum, yeah, this should be plus 0. Right? This should be plus 0. So we start with this to be 5. Right? This is 5. And then this is 3. Because it's 1 plus 2. And then it's 2 plus 1 is 3. Interesting. Why this is not right? Okay. okay, we will figure it out. 1, 2, 5. This one is 3. Next one is 2, 1, 2. This one is 2. I only want to handle this one first. So we go for usage limits. This one is max increasing group. Usage limits. And I need to print some stuff. I want to know what is the current I and what is the current usage limits I. Actually, we can do here. And of course, I also want to know the result. Okay, let's do this. 90. The last one was 3, 3. The last one is 0. I is 0. Ooh, last one I is 0. I sort it. Oh, I got it wrong. I go from this to this and then the... Oh my god. Okay. So we should just say for IU in enumerate sorted usage limit. Okay. And I should say n equal to len usage limit. Of course, we should do this. N equals res equals this. Delete this. And we say, nope. We do this. Res equal to minimum res. U plus n minus I divided minus 1. So this should be plus 2. Right, n is 3, yes, so plus I minus 1. So D2J, okay, alright. Let's check this. Alright, let's go 13K and take a look at this. Run it. Try it. I'm not sure, but let's try it. Nope. Did we always get some? We got some. So this is not right. Output is 2 because we got 2 on each one. 1, 2. Hold a second. How did you do 2 to 2? So 2, 2, 2. 0 can appear 2 times. 1 can be 2 times. So I can do 0, 0, 1, and wait, hold on. No more than number, so it can be no more than 2 times. So I already use it 2 times. Alright. In total across our groups, each group consists of distinct numbers. Okay. Means that no. So hold on, this one I can do I can do 0, 1, 2. Every I had 1 left. I can do a 0. I can do a 0, 1. How'd you get it 3 groups? Zero, 1, 2. 0, 1, 2. Oh my. Yeah. So basically it says if it's 0, yeah, and next one is not 0, 1, you split it out. Next one is 0, 1, 2. And then you have these two can do the second one. Basically, what we're saying is we don't always use this one. Okay, the lesson learned. Maybe we have to DP this. Maybe we have to DP this. It's not as straightforward. I mean, we can still rank it. It doesn't really matter, right? It doesn't really matter which number gets used what. So let's say we sort it, okay? And we say at the end, each number can only be used a certain number of times, right? So if a number gets used one time, it's just used one time, right? And then at one time we can do that by itself, or some number, right, will be used by itself. And then we move on to the next one. Now the minimum number is have to do 2. Okay, so when you do 2, you can either choose the current number, right, to do 2, or you can choose the next number to do 2. Okay, so for one thing, we can get rid of all the numbers that get repeated more than the length number of times. Those are useless, right? Those are useless. So we only have the numbers that can repeat less than a total length of times, and they can at most appear in those number of subarrays, right? Like in here, 0 can appear in 2 subarrays, okay? And then 0 can appear in 2 subarrays. If we want to create more subarray, then what the requirement is someone need to start, right? If like I use 0 already, now 0 becomes the smallest, right? Now 0 becomes the smallest, so I don't use 0 the next time. I use maybe this is a good idea. We find the one with the maximum, right? We find the one with the maximum, and then I use it. Now we have less, that one has less, and I put it in. And next round I pick also the largest. Now I use that, right? And I put it in. And next time I pump out, I use the largest again. But each time I do this, other numbers need to decrease. What do you mean other number need to decrease? Because they got used as well. Right? That means biggest number, use it, okay? Now, if the bigger number shows the biggest, then we start from here. Now we should take the highest 2 numbers, right? Highest 2 numbers. And if the biggest number becomes, then we should pick the other one. And those will take 2. So most will run it n times, and then each time you do on squared log n. Okay, I have an on squared log n solution for this, which is going to time out. So that's not going to work, but I kind of know. Yeah, so you take one from the biggest, the next round you need to take so if the biggest is bigger than its second biggest, I think that situation is fine, because as we decrease, right, they will decrease in line. They'll decrease in line, right? So this solution will work. This will work if everybody is, if it goes like this, the usage. So as we get rid of this, then these two will be in line. Right? Next time we get rid of this, everything will drop in line. So it is depending on how much this each one can go. But difficulty comes when we have the same usage. We have some same usage. And if we have the same usage, this is interesting, like this 2, 2, 2, right? 2, 2, 2. I use this to become 1. I actually should say here. I use it to become 1. So the next round I cannot start here. So this has to go to the front. Right? This has to go to the front. And then we shall check. Then these will go in line. Right? These will go in line. Because in the current round, I need 2, so they will go in line. And then next, all I need to check is if these two are still in line. What if they're not in line? I mean, we sort it's gonna be like this, right? It's gonna be none decreasing. So what if I have something like this? Okay, first one is good. Second one, these two need to be in line, right? And then this one gonna drop to 1. And this one is, so this is gonna drop to 1. Next, these two are not in line, right? Therefore, this need to go first. So we need to move these two to the front, right? So now I have 3 of them. They need to be in line, right? Now these two are not in line, so this actually move in front. Then it will be like these. So we do it this way, right? And then these two are not in line. So next to start, come here. And then we can count, because when this moves to the front, it's the same as a loop back. So I can go find out this, the current end. So we can say start and this is end. Right? So we have a long list of numbers. And I say start and end beginning is this. And then we check these two. If it's good, then I move the end towards some, like they can together drop, right? Together they can drop by 1. Okay, they drop by 1. And then we need to compare these two, right? And if they're this is the new end. No, we need to move this one forward. So if given us 2, 2, 2, then this one, the maximum you can do is plus 0, plus 1, plus 2, right? So this maximum you can do is 2. Maximum of this is 3. Maximum of this is 4, right? Maximum is 2 on this. And then maximum on this, because it can be included in the length 2. Because right, length 1 if it don't include it. Okay? Length 2 include this. And length 3 include. That's why I can do maximum 3. And this one, length 0 don't include it. How come this one is right? 0 don't include it. 2 don't include it. So length 3 and length 4. Right? This one allow length 3 or length 4. But we don't have length 4. So this doesn't matter. This maximum is also length 3. Right? Maximum is like length 3 included. Oh, and this one has an extra. Because we can, this one technically can have 4. So we have 1 opportunity extra. Right? 1 opportunity extra. So whichever opportunity this one has extra, because this only need to contribute 1, right? 1 of them to make length 3, right? Because maximum is 3, right? Maximum is 3. And this contribute 1 already to 3. So this has a 1 extra. So we plus 1 extra. And this is a minus 1 extra. So maybe what we need to do is we check this. We say how many, like this one is minus 1 extra. This one is 0. This one is plus. So this one can counter this, right? Can counter this. Maybe we go through this process, and each time if something can counter, we just we counter. And at the end, if the value is large, if the counter, the extra, is larger or equal to 0, that means we have more values to counter, which means we can get to the maximum result. And if it's smaller than 0, we can actually use this as an example, right? This is a 1, 2, 2, right? And then we can plus 0, plus 1, and plus 2. So this one, we have a minus 1. This one is a 0. This one is 0. So in total, the extra is minus 1 extra, which means we cannot reach 3. We can only reach 2. Because one of them, one of the length, we cannot make because we have a minus 1. And this one is same, 1, 1. So plus 0, plus 1. This one's a minus 1. And this one is a 0. So at the end, it's 2 minus 1 is 1. This is a very interesting idea. It's a very interesting idea. Let me just try this. Also, so we start with n equal to len, usage limits, right? So go from right to left and go from right to left, it's the same. And what we want to do is the debts, okay? Debts start with 0, and then we say for I, u in enumerate usage limits. Actually, no, sorted. All right, sorted this. Then we say the that's plus equal to n minus what the current one can afford, which is u plus n minus I minus 1. So this thing, u plus n minus I minus 1, this tells me what is the maximum number of, okay, I can just say u plus n minus I minus 1 reports the max number of groups the current repeat of u can produce. Since n is the max number of repeat, max number of groups available, n minus u plus n minus I minus 1, which is equal to n minus u minus I plus, so be I plus 1 minus u, right? Which is equal to this I plus 1 minus u. So we can do this. I plus 1 minus u, right? This is the debts or surplus, right? Or surplus. Each number contributes, right? Contributes to achieve the max number of groups. Now, any number with a surplus can help. I can replenish another number, right? Another number with a deficit. So we accumulate the debts, right? And at the end, we're gonna return n. If debts is a positive, then we return n. If debts is a large or equal to 0, else n plus debts, right? If it's negative. If that's a negative, so n plus this, and we shall do the minimum. Actually, this, I think I can replace this. Hold on. We can do minimum of n and n plus debts. Okay, new solution. Let's hope this one have a better luck. Of course, I will put 222 into it. Give it a shot and a pass. It does not pass. My goodness. The first two doesn't work. Oh, I was so confident in this. How? Output 1. The first one output is 1. That's bonkers, man. I just print u, well, print I, print u plus n minus I minus 1, and print I plus 1 minus u. Oh my goodness. I plus 1 minus u. All right, so the first one, I is 0, u is 1, and u plus n minus I is 3, and the deficit is 0. That is correct. Next one, oh, I think I did it wrong. I think it should be this is not right. Yeah, sorry. I think this is minus n. which is going to be u plus n minus 1. Yeah, that's n is deleted. Jesus, it's gonna be this. All right, it's gonna be this. It's on the other side. So I got this wrong. Okay, so I just need to delete this. U minus I minus 1. All right, is this right? Okay, coming here. Okay, this is correct. Yeah, that's interesting. It's still minus 2, right, at the end. Oh, of course, because I printed this one wrong. That's fine. Okay, let's try this one more time. Come on, this one should be right. Come on, let's go. I think it's very smart, right? This deficit idea is very smart. Come on. Deficit. Ugh. All right. At least did we get more answer correct? 664. All right. So I think we doubled the previous one. No, we didn't even double the previous one. Okay, so this method has some inherent issues. All right, I thought it's so smart, this deficit idea. All right, it's fine. Let's see, what is this? 115. Output 3, but only 2. Okay, so this is plus 0, plus 1, plus 2, right? So this one, theoretically, I can make 5. This is make 2. This is make 3. So here I have a... I shall cap it, right? I shall cap it. Is the debts or surplus? Also, no, I cannot cap the surplus. Can I cap the surplus? So in this case, this one will have plus 2 surplus. This one has minus 1 deficit. And this one has plus 0. So at the end, I say it's plus 1, right? And I say it should be good. But in reality, it's not. I can only make 2. Okay, so this is 0, 1, 2. So I can do... so this is 0, this is 1, this is 2. So I can do 2 by itself. And then 0, 1. Yeah, so that can be 2 by itself, 2 something, 2 something, and I have 2 more 2s that we can use. Oh, but those 2 more 2s are not useful. It's not useful because everyone has had it. Oh. But why the other one can use it though? So the surplus in here is not useful. Like I do have 2 surplus, but this one already occupied every single position. Right? This already occupies every single position. And this one can only have 1, which is pointing here, right? And this one has a minus 1, right? It has a minus 1, which means I can do here, but I cannot do here. This is deficit. Then I say I can use this to replace, but I cannot use this to replace because we cannot have 2d1. So in some circumstances, the surplus is not real. Then when is the surplus real? When is the surplus real? So we have this idea earlier when we're handling a 2-2-2 situation, right? And a 2-2-2 situation, again, plus 1, plus 2, plus 0, 1, 2. So this is a 2, so I have a minus 1 surplus. This is a 3, we have 0 surplus. This is a 4, right? So I have a plus 1 surplus. We have a surplus here. We have a surplus here. And because it technically it only serves one, right? Therefore, there is allowance. So we have a +1 surplus and a allowance. Allow. So this one, in addition to its own position, is allowed in 2 more positions. This one, in addition to its required position, has allowed 1 more position. And this one has a 0 allowed position, which means if I have surplus here, I cannot use anywhere else. Holy. Which means if I want to change this, so reports the max number of groups the current repeat of U can produce. Is n is the max number of groups. This is that's all surplus, right? Surplus. Each number contributes to achieve the max number of groups. Any number with a surplus has the capacity, right? Has the capacity to replenish another number with deficit, with a deficit. However, there's a big however here. However, each number also has a max capacity to use its surplus, right? Surplus. For instance, number at index 0 has n-1 extra capacity, whereas number at index n-1 has 0 extra capacity, right? In other words, if we have surplus at index n-1, those surplus cannot be used to replenish any deficit, because the number at index n-1, that is a very bad way of to say that. This is just num usage limits n-1, right? It's easier to represent. Has 0 extra capacity if we have surplus. We can replace this, say usage limits 0, right? And then in other words, if we have surplus at index, the surplus cannot be used to replenish because usage because the number, right? Because the number at because n-1, right? How do we? Because usage limits 0. No, n-1 already appears, right, in all groups, right? Its extra capacity, its surplus is useless. Its surplus is useless. Therefore, when we compute the net debts, only the surplus that is within the capacity can be counted towards the net debt. Oh boy. So we can say debt D will equal to U minus I minus 1, right? And if it's smaller than 0, then we have a real debt, so we need to add it. If it's larger than, then we need to know how much we can. So we say if D is smaller than 0, then debts plus equal to D. If it's larger than 0, debts plus equal to the minimum of the surplus You know what? Let's call it DS. Okay, this debt or surplus. Right? If it's smaller than this, now it is a debt. Now we do this. It is a surplus. But we need to do the minimum of this and my capacity. What is your capacity? Your capacity is n minus I. Is your capacity. That is not right. It's n minus 1. That is your capacity. So for here, the capacity is 2, right? N is 0. The capacity is 2 because I fill 1. I have 2 extra. So capacity is 2. Capacity is 1. And here capacity is 0. So it is a surplus, but we can only supply. We cannot supply more than the capacity. We cannot supply more than the capacity. So with that, we can delete this line. And then we do this. Okay, let's put this one in. Man, this is an interesting problem. Come on. Come on. Okay, these are right. Let's submit this. Let's go. Let's go. Ugh. Mamma mia. Mamma mia. Alright. What the hell is the problem here? 1771. Alright. Oh boy. Alright. And then this is so man. I need to sort this. Okay, so it's 1177, right? So it's plus 0, plus 1, plus 2, plus 3, and is equal to 4. So here I have, so this is DS line. This is the capacity line. So the DS line here is 3. Okay, so because it's 7, 8, 3, and 4. Right? So the surplus is 3, but capacity is 0. Right? Capacity is 0. So basically we don't have any capacity here. Right? And this is 8, so surplus is 4. And the capacity is 1. So if we want to supply, this one can supply 1. And here is surplus. There's no surplus. There's a deficit. We have this one, right? Deficit. And this is a 0. Okay, so we don't care. Which means, in the end, I say this one can be used to supply this so that we can reach 4. But the answer is 3. That is interesting. Hold on. So that's basically 0, 1, 2, 3, right? So I have 3 something, 3 something, and then 3 something, okay? And extra 3, another 3 is useless. Okay, for 2, I have 4 surplus. So basically we have 2, 2, and 2. And I have 1 more. Oh, wait, hold. Your capacity is... No, I think I computed capacity wrong. What's the capacity of this? This one has 3. At this position, you can fill 3, okay? You can only fill 3. So your capacity is... The capacity is also 0. Wait, hold on. What am I doing? Solving the problem. It's very fun, very fun. I do some problems and then keep your mind sharp at all times. Hold on. I think I got the capacity wrong. Okay, I got the capacity wrong. So these are the surplus, right? And the capacity for this, capacity for this is how much additional that you can supply, right? How much additional you can supply. So at this one, they like that. I say I have one capacity. That's actually not. I mean, technically, I have one capacity I can supply here, but I can't, right? I can't. Again, we have to go back to the previous idea of this capacity thing, right? If I have more and some other place, because this already filled, this number filled everything, right? You filled everything. I think it's the capacity computation is not right. We say capacity here is 0 because I don't have anything, but the capacity is computed by. So here I need 3, right? And I have 3. Then we don't have any capacity left. But again, go back to this. Go back to this. Why does this one work? This one works because in here I need, so this is plus 2, right? Plus 1 plus 0. So I have 4, right? I have 4. And I have plus 1. I have plus 1 capacity. No, plus 1 surplus, right? And that surplus, because I only need 1 of this, right? And then I have 2. It's not 2. You can fill in only 1, right? So every number has, at this position, every number at a position has some rows to fill, right? Every number has some row to fill. So this one is supposed to fill this row, right? And then we have these rows become its capacity. That's why this plus 1 is its capacity, right? And then we move on to this. If it fills these two, the maximum, you look great.
I'm paying for.
Okay. Right, so it fills these two. If I have capacity, I can fill this one if necessary, right? If necessary. So for each number, I need to find out the actual capacity. And the actual capacity that it can, the additional, right, the rows that it can fill. And for each one is the rows in front of you, right? And then for, if you fill your current, right? If you fill your current, then you have capacity to fill somebody else. So in this case, I fill it and then I have plus 1 capacity, right? Because in this position, you only need 1, but I have 2, so I have plus 1. So this plus 1 can be used, it's the actual capacity. And here I have 2, which exactly required, so it doesn't have extra capacity. And here I have 2, but I need 3, so I can borrow this 1. Therefore I can do 3. So in this case, at the first is 1, which fulfilled. At here is 1, but I don't have any capacity from the left, right? I don't have any capacity, so this one cannot fill 2, right? This one can only fill, so we actually have a deficit. Right, this one we have a deficit, and then we're looking at this one. This one is good, right? But its surplus cannot help, and this one is good. So at the end, we have minus 1. So we go from left to right, and at each position, I'm gonna have to delete everything, right? So what I'm thinking is at each position, I know how many. At each I, right, we need u, if u, right, if u is equal to I plus 1, we have exactly the number of repeats to achieve the max number of groups, which is n, right? If we have more than n, the extra, right, the x, if I have more than n, then n minus u, no, u minus, hold a second, who minus what? So I plus 1 is, so u minus I plus 1, u minus I plus 1 is the surplus, right? Then is the surplus, but not all the surplus can be used, because at each position, right, the capacity for the surplus is limited to what? To the capacity to surplus is limited to, so you can only have, so you can only help the ones n minus I, right? N minus I minus, so like if I'm here, if I'm first position, and my surplus can help everybody to this, so n minus I minus 1, right? Because at each position, the capacity for the surplus is limited to this. For example, right, for instance, the surplus at I equal to 0 can help numbers at I equal to 1, 2, 3, all the way to n minus 1, right? All the way to n minus 1. And anything more than that cannot be used, yeah, because we just have a limit. So the capacity is n minus I minus 1, which means in this case, if this is not 2, right, the first one's not 2, if this one, let's say, is 100, right, which means my capacity, my extra, is 100 minus 1 is 99. I have 99 extra, but that doesn't mean all the 99 extra can be used. I can only use 2 of them, which is n minus 0 minus 1, right? So that is the capacity. So what we want to do is to compute, now if u is if u is larger than, right, if u is larger than I plus 1, if u is smaller than I plus 1, then we have debts which can be paid by the surplus, right? By the surplus from before. At the end, we want to compute the net debts. If it is larger or equal to 0, we can achieve max number of groups n. Otherwise, we achieve n plus debts. Okay, so we can say ds is equal to u minus I plus 1. If ds is smaller than 0, then debts plus equal to ds. So this is the debts. Else, then debts plus equal to the minimum of ds, and maximum capacity is this, right? This is the maximum capacity. At the end, we'll return n if debts is larger equal to 0, or now it's just a minimum of n and n plus ds, n plus debts. Okay, let's run this. Hold on, I'll be back. Solving this tough question. It's one of the more interesting ones. I feel like I'm getting a hang of it. Right after LeetCode, we'll talk about payments. No more payments. Right. Hold on, I need to feed my cat. Oh no, it's wrong again. Oh. Oh, a lot of wrongs. Damn it. The capacity is not right. I go from left to right. If I have debts, I increase the debts, and then I have capacity, right? At the beginning, the first one I have capacity. Yeah, because I only fill 1. So 4 minus 1, and then hold on. So the first wrong is 212. Okay, let's check 212. Why 212 is wrong? 212 is 122, right? So what is needed? This is need 1, this need 2, this needs 3. I need 3, right? So here your ds is 0, this is 0, this is minus 1. Okay, and my output is 3. That's interesting. U minus, right? U is 1 minus I plus, this should be 0. Right? That should be 0. Let's put a 0 here. And the last one, I is 2, so this is 3. So this is minus 1. Nope. Hold on. This one need to debug this. Oh. I have high hopes for this one. Come on. I have high hope for this one in general because I feel like this is correct. It makes sense to me. It doesn't work. Let's print. No, let's do this. let's print. I want to know the I, the U, the DS, the debts. Oh, n minus I minus 1. This is the what I call a capacity, right? And then I want the debts. Okay, let's take a look. That is interesting. I printed only once. Wait, did you save? I think I saved, right? What? How could I just print it once? Oh, dear me. I put a return on the wrong line. Alright, it's still wrong. Oh, it's the last one. It's still the last one. It's still the last one, man. It's still the last one. Let's GCC this. Let's put this one here. 1771. And the expected is 3. Okay. The debts at the end, because the debts initially 0, 1, 1. So I have debts 7, 2, right? DS is 4. Capacity is 1. Therefore, I cancel this. How do I have capacity as 1? That doesn't make any sense. How do I have capacity 1? That doesn't make any sense. This one, because I feel this. Oh, dude, capacity is not -1, it's -2. Because for this, I have capacity here. I have capacity here. Technically I have capacity here, right? It is 3. And then for this one, right? For this, 0, 1, 2, no, 1, 2, 3. This one I need to be 3, right? But I have 4. And I already filled all of them. So I don't have any more capacity. I don't have capacity in this one. Because I need 3, right? But I have more, so this one has a deficit. Right, so 2 has a deficit. Feels so close, but it's also so far away. The second one, third one, and the fourth one, right? So here, we put 0 here. We have no more. This one will have 1, which we fill here. And this is the deficit, right? This is a deficit. We have a deficit of -1. And this one, we have 7. So we can fill it. 2, 2, 2. We fill it. And we have an extra 4, right? But its capacity is only 1, which is fill the one in front. I cannot fill the one to the left. I can only fill the one to the right, which means all the deficit, which means I can only fill the deficit towards this way. I cannot fill the deficits on this way, because this deficit is here, right? If I find a deficit and I don't have any capacity to fill, then this deficit is just going to be deficit. So each time I have surplus, I record, right? I record how much surplus I have. And then if I have a deficit, I can use whatever surplus towards the left. So I need to keep count of all the surplus, right? And I have a deficit, I can use it. But if I don't, oh. Okay, so at each I we have a number of repeats to achieve the max number. We have is the surplus. And also it can be because at each position the capacity for the surplus is limited to this, right? Thus, we can only use minimum u minus I minus 1 and n minus I minus 1 number of repeats as surplus. Another important aspect is that the surplus can only be used to supply the deficit that happens to the right. We cannot use the surplus to replenish the deficit that happens on the left hand side, because all the groups on the because the current number already has filled all the groups on the left hand side. I'm not sure if it makes any sense. For example, given 1177, right? 77. The number 1 occurs one time, but it requires 2 times to achieve the max of 4 groups. Thus, we have a -1 deficit. The number 2 occurs 7 times, right? But it requires 3 times to achieve the max of 4 groups. Thus, we have a +3 surplus, +4 surplus. However, none of the 4 surplus can be used to replenish the -1 deficit because the number 2 already has filled all the groups it belongs to. There is the only capacity it has is to supply any deficit that occurs in number 3. Yeah, in number 3. So that's a very important distinction. Let me also add these things. Okay. All right, so we do this, we do this. So we need to keep track of the surplus. If I have a negative and I have a surplus, good for me, right? So we have debts and surplus, okay? So this is this, and then if we have a debts, then we need to check if we have any surplus at the moment. So debts shall be plus equal to surplus, this plus surplus. So these surplus are accumulated. So each debts I find, I can use the previous surplus to help me. but and then this is surplus. The plus equal to this, right? So each deficit can use the accumulated surplus from the left hand side, right? Each surplus cannot exceed its capacity. And then we'll do this. Is this correct? All right. Try this. Oh, my God. All right, it's been 1 hour and a half. I'm gonna cut it right now. There's just no point keep going on this. We'll get back to this tomorrow. I still like this idea, but I don't know what else did I do wrong. Well, we'll do this again tomorrow. It's an interesting problem.